Printing news Unpeeled, courtesy 3dprint.com. So today we're looking at the day's 3D printing and additive manufacturing news, and AddUp has opened its academy. So AddUp has partnered, and this was announced a couple months ago, I think, and they today have opened up their academy together with the WBA Tooling Academy in Aachen in Germany. So AddUp is providing a powder fusion system, the 350 Form-Up, and what the WBA guys will do is to provide training and technical evaluation and any kind of services related to design and also costing and later on qualification, actual production, manufacturing for tooling related additive manufacturing components, specifically in Germany, but maybe even beyond that as well. So the idea here is that rather than have to buy your own machine or go work with a service bureau, you can go to these WBA guys and they will help educate you on where 3D printing for tooling makes sense. If it makes sense for you, maybe your tools are too big or too inexpensive or could be better made another way. But they'll look at, before you buy a machine or before you invest, they'll get you started and help you explore how powder fusion tooling could perhaps make sense for you. I think from AddUp's point of view, I love AddUp, by the way. I think the machines are really good. They're kind of built from the concrete floor to be a real production machine. So I'm a real fan of what they're doing. But AddUp itself has been rather insular as a company. So this has especially been kind of limiting for them, of course. And this really helps open them up and helps people gain experience with their machines, and especially in Germany, it helps people get familiarize themselves with powder fusion through the window of AddUp. So I think this is a really great way to engage the market. It's a really great way to get a lot of more people kind of 3D printing. And I think there are companies like Boeing or whatever that will buy machines, will buy maybe even very many machines, but there's a lot of other companies that won't. So I'm really interested in any kind of news that we see emerging from people 3D printing without owning 3D printers and really doing industrialized production of really critical parts without actually owning the machines. So there's a gulf now. I can make a prototype very easily with a service bureau, or I could come in-house, take a couple of years, and then I can make parts, but we need a kind of interim. In a couple of months, I could make critical parts just outsourced for a certain amount of scale, a certain amount of price. I think that's a brilliant opportunity, and it's waiting to be filled. So I think I see this as kind of a portent or window into that opportunity as well. Next news is that Stratasys has bought Riven. Riven is a startup that allows you to take 3D scans of CAD data and compare your 3D printed parts with what you were supposed to try to get in the first place. What you can use Riven for is to kind of do QA and optimize your 3D printing yield, for example, your accuracy, and just overall the reduce the number of faults in your builds. What you can also do is, for example, use the software to come to a geometry for binder jetting much faster than if you were just doing it and trying to kind of figure that out by yourselves. What you can also use it for is, for example, to qualify parts or machines or new materials, dial those in much quicker than you could. So I think it's a very powerful tool, and it could be used to really industrialize things from kind of going from a lab to a fab kind of scenario, and if you want to do a real closed loop kind of printing experience, this could also be a part of that as well. So I think it's very very exciting for GrabCAD. This will be incorporated into GrabCAD out of manufacturing and be just extra functionality for the users, and just give you. Hopefully, this will just give the existing installed base of GrabCAD a lot of extra functionality they could deploy to get to parts and get to industrial quantities of parts faster, and that could be a really, really good kind of thing. There is a new 3D printing and technology in town. This is done by Saccone and Rebecca Gallivan. They are at CalTech. They're part of the Greer Group. That's around Professor Julia Greer. They are not as known as they should be, I think, in the additive manufacturing community. They do a lot of nano materials, architected materials, that kind of thing. And they also do 3D printing work. And I really do think that these guys, I had not heard of them, I'm sorry, to my detriment. And I just opened the entire can of worms, it was this morning or something like that, when I started reading papers by these guys. And so you should actually maybe kind of take a look at them as well, because they're doing some really exciting work. One of the things is a couple months ago, they did a paper, I think it was a couple months ago, I'm not sure. They did a paper, hydrogel derived metals and ceramics. So that's the process you see in front of you in the image. And they have a number of different paths to starting with a hydrogel, starting with kind of an architected geometry in that hydrogel, and then obtaining, as a result, metal and ceramic. This paper that they do now is essentially a refinement on that from metals and a different type or similar type process to get metal parts. So what they're doing is essentially they do really, really tiny resolution. They're talking about 40 micron type parts, really, really high detail size, detail definition. What they do is they essentially use vat polymerization to make a hydrogel into a particular shape. That shape is subsequently infused with metal precursors. So maybe at this point you're thinking, oh, wait a minute, it's slurry SLA, right? No, it isn't. So first they make the shape in the hydrogel, then they put the metal precursor materials in that shape. Then they calcinate the shape. Calcination is like a heat-derived kind of purification process using coke for like the petro derivative, also in glass processes and cement and a couple of different things. And then they will, through that calcination process, then a metal, that scaffold will be magically transformed into a metal component. This metal component could be very finely detailed and very, very tiny. So this is very, very different than slurry SLA. It's also very different than binder jet and vat polymerization and all these things. Now, a lot of people have the idea that we were looking for the best 3D printing technology. This is not exactly the case. You know, for desktop, maybe if you want like one machine for your prototyping lab or something, maybe. But we're even in a prototyping lab, we're seeing people get like, you know, an Ultimaker and then a Foreign Labs machine to just complement each other. And a lot of times, if you're looking to industrialize a process, if you're looking to make millions of something, you're not really interested in if this technology is a little bit better than slurry SLA or a little bit better than binder jet. What you want is for that technology to be uniquely good at printing precisely what you need to print at the yield, the accuracy, and the price point that you want. And that's what happened really with these previous technologies when we saw DLP being used at scale, for example, for hearing aids. And when we see a lot of technology being used, for example, for our EBM being used for turbine blades, right? ABM didn't make sense for turbine blades initially, but once the Avio Aerial people industrialized it for turbine blades, it was also all of a sudden really logical what they were doing. And since then, it's been a major production technology for these things. So it's about finding the perfect technology for that one application at that very moment. And so, you know, this doesn't have to, you know, knock up against the installed base that we have. It doesn't have to be better than slurry SLA for certain parts. It just has to be really uniquely better suited for this one application that could make millions of parts. So think, for example, think of, for example, if you use this technology to make sensors or kind of strain sensors or things like RF antenna arrays or waveguides and things like that. If you'd be able to make these materials in, let's say, aluminum or copper, and be able to get a better reception, let's say, or better clarity through these particular shapes of that particular shape that is best for these RF antenna or waveguides, it doesn't really matter that there also is a technology called pattern bit fusion. That would be really unique. And if you think about this waveguide thing, that's going to be on every single satellite. That's going to be on every single space vehicle, and a lot of military vehicles as well. And maybe far beyond that, of course, if the technology gets further commercialized. So this could be very exciting. We've seen similar things. I don't know if you remember, but we discussed a while back also a carbonization kind of SLA or 2PP slash carbonization type technology as well. And this seems to be a very fruitful kind of field to get to new AM technologies to do different things than we would expect than with just lost wax casting or other kinds of processes that we were doing before. And this again is a relatively new IP stack. That is a new way of deriving products. And it actually looks like this could be industrialized as well, building on advances in vat polymerization, building on existing vat polymerization libraries, and building on a lot of other things that are going on. So to me, this is, you know, we don't know if this technology is going to make it. Of course, it's very early days yet, but to me, it's the right time in the industry to be developing technologies that are fundamentally different and could fundamentally fit a particular application window much better than the technologies that we've had. So this, I thought that what the Greer Group and these guys have been doing is very, very exciting indeed. Thank you very much for your time today. My name is Joris Peels, and this is another episode of 3D Printing Unpeeled, courtesy of 3dprint.com. Have a great day.